Welcome to today's video on trigonometry and right triangles. The first thing we need to do is to define within a right triangle the different kinds of sides that you have. We'll let theta be this angle here. The side opposite the right angle is always called the hypotenuse. The side opposite of the angle theta is called the opposite side. The side next to the angle theta that is not the hypotenuse, that is the adjacent side. Now it's important to it's important to understand that if you drew a right triangle, that theta could be either this angle, or if it's up here, the hypotenuse stays the same, but then the opposite and adjacent sides would change. All right, so there are six trigonometric functions of theta, and these are ratios. There's what's called the sine, and it's abbreviated SIN, and that is the opposite side over the hypotenuse. There's the cosine, which is abbreviated COS, and that's the adjacent side over the hypotenuse. And there's the tangent, which is abbreviated TAN, which is opposite side over adjacent. There are also three reciprocal functions. There's the cosecant, which is CSC. It's the reciprocal of the sine, so it'll be hypotenuse over opposite. There's the secant, which is SEC, which is the reciprocal of the cosine, so it's hypotenuse over adjacent. And then there's the cotangent, which is adjacent over opposite. So those are the six trig functions that you would find of an angle in a right triangle. Now, these three are the main ones, the sine, cosine, and tangent. Those are the ones you see, they have buttons on your graphing calculator. To remember those, there's an expression that you probably learned, which is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That is SOHCAHTOA. Some examples here, this right triangle here. Some examples, find the six trigonometric functions of the angle theta. Well, notice we only have two of the sides. So to find the missing side, we have to do the Pythagorean theorem. So x squared plus 9 squared equals 13 squared. 9 squared is 81. 13 squared is 169. Subtract 81 from both sides, you get 88. And then take the square root. And when you simplify that, it's 2 rad 22. So now finding the six trig functions, the sine of theta is opposite over hypotenuse, so it's 9 over 13, which means the cosecant, which is the reciprocal, is 13 over 9. The cosine is adjacent over hypotenuse, so it's 2 rad 22 over 13. The secant, which is the reciprocal, is 13 over 2 rad 22. But remember, we have to rationalize the denominator, which means multiply top and bottom by the square root of 22. So it becomes 13 squared root 22 over 44. the tangent is opposite over adjacent, so 9 over 2 rad 22. Remember, we have to rationalize that, so it becomes 9 rad 22 over 44. And then the cotangent is the reciprocal, so it's 2 rad 22 over 9. The second example, you draw a right triangle, and it says assume theta is an acute angle in a right triangle. So we'll make theta this one. Satisfying the following given condition. Evaluate the remaining trigonometric functions of the angle. Well, it says secant of theta is 3. Remember, secant is hypotenuse over hypotenuse over adjacent. So that means the hypotenuse is 3 and the adjacent is 1. So you fill that in. Now you need to do the Pythagorean theorem to find the missing side. So 2 rad 2 is equal to x. So the secant is 3. The cosine, which is the reciprocal of the secant, would be 1/3. The sine is going to be 2 rad 2 over 3. That means the cosecant is 3 over 2 rad 2, which remember you have to rationalize, so it becomes 3 rad 2 over 4. The tangent is 2 rad 2 over 1. So the cotangent would be 1 over 2 rad 2, which you rationalize to the square root of 2 over 4. The last one, you have a right triangle, and here's theta, and you have, remember, cosine is adjacent over hypotenuse, so the adjacent is the square root of 3, the hypotenuse is 2. To find the missing side, you could do the Pythagorean theorem, so you have x squared plus square root of 3 squared equals 2 squared. So x squared plus 3 is equal to 4. X squared equals 1, so x equals 1. So you have 1, square root of 3, and 2. These are the ratios of a 30, 60, 90 right triangle. If you remember from geometry, and some of you may have talked about it last year in Algebra 2. So always opposite the 1 is a 30, always opposite the 2 is the hypotenuse, and always opposite the square root of 3 is the 60. So theta is equal to 30. The angle was 30 degrees. That would have that cosine. All right, I hope this video has helped. Hope you guys have a good weekend, those of you that are not in class on Friday with your illness. And I will see you guys all on Monday. Have a good weekend.